Good day, my name is William Armstrong and this is my video assignment giving a demonstration of my teaching philosophy. To recap from the earlier assignment, my teaching philosophy is learning while doing. I believe there is an important emphasis on learning because it places it on the student, not the teacher. This is not my classroom, it is a space for the students. It is not about me, the teacher, it is always about the student. So by applying Pagut's theory and Vygotsky's theory and applying them with constructivism, we're able to take learning fundamentals and apply it in the classroom. I believe that starting with a concept, a demonstration, an activity, and then applying it with the students and then going to the classroom, it provides context. I don't want to start with an in-class lesson on the board and then trying to apply it. I believe that if the students are exposed to the content in the environment, such as John Dewey has described, by bringing the students into the environment in which we are learning about, providing them the context of the information, and then bring it back to the classroom, it will tie everything together in a neat bow. I believe providing that context is extremely important. And by being involved with the teacher in the lesson, they're able to work with Vygotsky's theory of social development. And when the student is exposed to a concept and then is asked to demonstrate it, it allows them to critically think and demonstrate their own ability of understanding. It's not so much the correct answer, it is about the thinking process. In this video, I have asked for someone's help who has agreed to do this with me. My younger brother, Matthew Armstrong, has agreed to do this and come on video with me. So say hi.
Hello.
So we're going to get into the demonstration now, and thank you. So today's lesson, we are going to be going over electricity, specifically 12-volt automotive systems. Electricity is deeply rooted into most forms of transportation, but today we are going to be focusing on DC current. This is going to be focusing on primarily a grade 12 classroom, as electricity can be a difficult concept to grasp because we can't see it, smell it, hear it, or taste it. Only in the worst cases do we actually feel it. Of course, in all settings, we would not be working with any kind of current that would actually harm a student. We will be using a 12-volt, 2-amp battery. So to start off this lesson, we're going to be discussing circuits. There already would have been some context about circuits beforehand. So for this demonstration, we need to understand that we have a battery. Our electrical symbol for battery is this. We have positive and negative. So this is our symbol for battery. Following the battery, we need wires, of course, to connect everything together. So we're just going to use a simple line for our battery, for our wires. So we got lines coming off of the battery. And what do we need? We need a load. Our electrical symbol for load is this. That is a light bulb that will illuminate when the circuit is completed. Now, we need to be able to connect our load, our light, to our wires. But there's something very important here. If there's any kind of issue, we can damage the battery, we can damage the light, so we need some kind of circuit protection. In that case, we're going to use a fuse. The electrical symbol for fuse is that little squiggly right there. So we have our power supply, our battery. We have our load, we have our light bulb, we have our wires connecting it all together, and we have our fuse. So now, Mr. Armstrong here, Matthew, is going to take this fundamental knowledge and he is going to apply it using tools and actually create his own circuit. Pause. All right, so we have gone over our wiring schematic, which was done with the class. We have our electrical symbols and how to build a circuit. Now we're going to take that information, and Matthew's going to come here, and using the tools we have, he's actually going to build his own circuit. So I'm going to trade places with him here.
So I have to take, are these leads?
Yep, those are the leads there. Okay, well, what's the importance of having those?
Isn't it just used to help connect things and
Exactly. If things aren't connected, then how are we supposed to make things work? So continue on.
That one goes in here, like so. And I need this side.
Well, how is that going to work? Maybe, what shape is that?
Oh no, it's not going to work because this is the clips.
Yeah, maybe we'll use that other one. These are called banana clips. What's nice about these is they're interchangeable with kind of adapters on there. So we'll put that together like that.
Okay.
So we have our battery here in our lead. What was next in our diagram? The fuse. Where's our fuse here?
Right there.
Right there, okay?
Yep. And that clips on, like so.
Right there. So what's on the other end of that fuse?
It's the light.
It's the light, okay. So we got our light right there, yeah.
That connects to this end. Does it make a difference which end it connects to?
That's a great question. No, it does not. In this case, it does not matter.
I'll do this end just...
So it might be easier if you use that other end to clip onto the exposed wire, though. Does that make sense?
Oh, yeah.
Yeah,
It
okay.
has a clip. Right.
Yeah.
And so that would connect like that.
Yeah. Okay, so now on our other end of the light, what do we have?
It's just wire, no?
Wire, that's right. So let's find some wire. I think we got some leads right here.
And so this end connects.
So maybe if we just go like this, maybe if we just...
Oh.
There, now it's connected.
Okay.
And how are we going to attach this back to the battery?
I need another set of wire, or is it just a banana clip?
The banana lead, that's
Banana.
right. So we got two different styles here. We got two different ends. What end is going to go inside of there?
The male end.
That's right. So I'm going to take that.
And then this
And
one just-
let's see if this works. Let there be light. So, Matthew, we have our power source.
Yep.
We have our wires that connect everything together.
Yep.
We have our fuse.
Yes.
And then obviously our light that lights up.
Yep.
Can you tell me the importance of this? Oh, what just happened there? The light went out. Why did that happen?
Is the
Yes, that's
It's
right.
connected.
So for this to work, things need to be connected, right?
yeah.
So this would be called an open circuit. It's open, it's not connected.
Correct.
This is a closed loop now. It's closed, it's one continuous loop. Very good. So you were able to create this diagram with me. You were able to take these different elements, these different components, and you were actually able to build your own circuit. What you essentially did here was you created the headlight. This is your headlight switch on and off. If we had a second headlight here, you would have just built a headlight circuit. Thank you. So thank you very much, Matthew, for being a part of that demonstration. As you can see, we were able to take a hand-drawn diagram that the students would be equally involved. For the sake of time, we had to move a little quickly through it, but in practice, this would be an engaging conversation between the class and the teacher. We're not segregating teacher and student, giving a lesson, well, they're back there and I'm up here. I'm actually in the middle of the lesson with them. Following the discussion of the different elements of a circuit, different things we need, Matthew was able to take those things and actually build his own circuit. He actually did the thing. By being engaged with him and probing questions with Matthew, we were able to work on Vygotsky's theory, where we were able to discuss, have conversations, socially interact with each other. This could also be done with students, where they're asking each other questions, trying to elevate each other, maybe in the use of handouts or worksheets. And by asking Matthew questions like open circuit and power supplies, we were actually able to work on cognitive development, like in Jean Piaget's theory, focusing on adolescent development. So now we return to the classroom, where we would actually discuss the parts of a circuit: the battery, the light, the fuse. So now when I say fuse or circuit protection, they don't just have a picture of something in their head, they've held it. They've held the fuse, they're able to make it work. They learned while doing. They were able to take the fundamental skills in practice and actually apply it in the classroom. So now when they're in the classroom, it's not just nothing. They actually have context. They learned while they were doing. So taking Jean Piaget and Vygotsky's theories and combining it with constructivism, I was able to help students learn while doing. In anticipating challenges for the learners and consequences in this lesson, Like in any environment, there's always a level of safety. As I alluded to in the beginning, we are working with power supplies that are not harmful to anyone, and all safety practices would always be engaged, always. Safety always comes first. Some challenges I anticipate, electricity can be a difficult concept to grasp, as discussed. So having multiple stations set up and multiple students asking similar questions might be difficult. The demonstration I did on the floor I really enjoyed because it put me in the center of things, but maybe it would be better on a chalkboard or whiteboard so everyone can see it all at once. Then we go and do the demonstration. That is something that I would have to learn myself as I do. Thank you very much for the opportunity to give this demonstration, and have a great day.